This is the first part. At the beginning we have to select the proper view, or you can use orbit like this. Now I have to place, I told you as a designer you should know everything about your design, where is the first part, second part. So I have finished the Arbor Frame. Now I want to place the plate, the jig plate and the face plate together. No need to place it twice, just once. Before that, I forgot to tell you that the first part, the jig or the arbor frame should be fixed. So I will click on the arbor frame, right click and make it grounded. Now I will constrain this plate. So this face will meet this face, apply, cancel, make it like this. Then constrain this edge. I want this edge to meet this edge, apply, cancel, move it that little bit down, constrain this edge to meet with this edge, apply, cancel. Now they are one part. I know that this constrain this surface to this surface, so they are mating together. Then move it like this. We need two holes to place in two holes here. Constrain axis to axis, as you see, apply, cancel. Still it moves like this or rotate like this. We need the other one. Enough. Constrain axis to axis, apply, cancel. Now they are one part. Next I have to say place the shaft. We have here the pinion shaft. Place the pinion shaft and know that the pinion shaft should go inside this hole. See, these teeth should be used to move up and down ram. I will place it later. So I will constrain axis to axis. Sorry, again constrain axis of the shaft with axis of this hole. Then we can constrain flush as example. Flush, make this surface parallel to this surface with some offset. I have to know the offset, how much, say that -20 as example. I will show you from the left side view like this. Maybe the distance is too much. By the way, this distance is design information, should be known from your design. You have to know exactly what is the distance. So make it -30. I think it's okay. Let me check from top view how or where is the location of the teeth. Yes, it's okay. Next step, we have to place. Now we let me place the ram. By the way, we have another way to place the shaft. We can use, instead of axis and mate face to face by make them parallel, we can use the insert one. We will use insert later with screws and different things. Regarding the ram should go inside this hole or inside this gap, so we can go to free rotate and rotate the ram like this. For the ram, I want to constrain, mate this surface, the side surface with this side surface. Still, see, it can move in X direction. Actually, let me go and select orbit to move like this and free rotate the ram like this. We can constrain so that this surface mate with the plate surface, apply, cancel. Exactly, this is what we want. I want the ram to go up and down only. I can't move it in X direction and Z direction, just up and down in Y direction. Now how the ram will go up and down? It should go up and down using the shaft. So the teeth of the shaft should join the teeth of the ram. When the shaft rotates clockwise, it will move up the ram. Counterclockwise, it will move down the ram. How we can do that? We can go to constrain. We have motion constrain. We have rotation, translation. So I will select rotation, translation. I will select for rotation, I will select the shaft axis, and for the translation, I will select this line. You can select any vertical line, no problem. I will select this one, and distance is very important. By default it's 90, around 93.5. That means one revolution by shaft, the RAM will go up or down by 93.5 millimeters. This is design, say that quantity we should get it from our design. For our demonstration, no need to think about it now, just keep it like this, apply, cancel. See, now like this. Next step, we have to place the handle that can rotate the shaft. So let me go and place the lever arm and put it here.